they want to light it on fire and burn it. So first off, let's back up a little bit here and show you our balloon molecules. This is what we're going to be doing today. Combustion is taking carbon compounds, which is what oil is. This mic is a pain. So you take the carbon compounds. The clip doesn't work. Carbon compounds. These are saturated with hydrogens, hydrocarbons I'll call them, right? So these chain carbons go on for a while, you know, there's 2, 3, 4, 5, 6, 7 carbons, 8, octane, right? But see, this is what we're going to be combusting here. You got this stuff floating on top of the water because this isn't water loving, remember? The polar molecules with O's, OHs, alcohols, things like that, that'll dissolve in water. Oil and water are the two liquids that do not mix. Emulsifiers mix them. Maybe that's what is a dispersant doing that? We don't know. We were talking about that today. What are the dispersants in the Gulf doing? We don't know. So the first thing they're going to do is they're going to burn the stuff on top. So here's the oil on top burning. What's it going to combust with? Remember, this is the same reaction. Photosynthesis is making carbon chains longer in the form of sugars. So these oils are from trees and supposedly dinosaur, dead little fishies or whatever. So the compounds that were made from photosynthesis were eaten by little animals or grown in the trees, which made long carbons. Say wood is cellulose, for example. So that's a typical combustion, is burning wood. Well, when we breathe in the sugars, we're combusting sugars, which are the same thing as carbons. They're COHs. This is just going to be a oil, so we're talking straight carbons, typical example here. So this with 3 carbons would be a propane. I don't have the end finish, but see how the end has 3 H's, so CH3. The middles are CH2s, so as these come along, this is exactly what it looks like, folks. Even though it's a liquid, this stuff is vibrating and the bonds in it, you know. So when you heat it up, what's going to happen is the oxygen is going to come along, O2. Remember, O2 has this double bond here. So this is what's called as being oxidized. And we're going to reduce the oxygen by taking these carbons that are going to get popped apart. Pop a carbon off. You're going to get carbon with an oxygen. And then you're going to get another carbon with an oxygen. What is this going to make? Tying it on there, I probably shouldn't tie it, but we're just going to leave it loose. This is CO2. So if there's enough oxygen around, this works out because CO2 isn't as bad as carbon monoxide. This has a triple bond in there, CO they call it, right? CO. Well, you can say see you later because when CO bonds to your hemoglobin, you're in trouble. It's bound for the whole life of the hemoglobin and it causes the 3 other ones, a total of 4 hemoglobin carrying parts in your white red blood cells are rendered useless. So carbon monoxide, not good. Now even carbon dioxide, we're not too keen on this because we're trying to get, the world wants 350 parts per million of CO2. We're at like 385 or something. So CO2 off the Gulf water burning into the atmosphere, not good. What I found at our last chemical conference up in San Francisco, one of the main pollutants that you would not think of as being a pollutant because it's a greenhouse gas, CO is going to get popped off. And this is really how it happens. You'll get a radical. You'll have a carbon with 2 hydrogens and lone electrons on there. This thing is a radical, man. This thing's ready to go. It's going to bond with something. In this case, one of the products of combustion is water. So what's not good up in the atmosphere is H2O vapor. When we were talking about the heat capacity of water in the ocean, right? It holds the energy in there. Well, H2O, you add a lot of heat and energy to it. This is an OH radical. See the electron there? This is one of the intermediates, they would call it, in the total combustion reaction, as our Velcro gets more worn. But see, that's what happens when you add a lot of energy to it. So we got water vapor is now in the air also. So we got water vapor. We got CO2. We got heat. Remember, we don't want the heat up there. We've got the greenhouse gas thing going. Well, what is 78% of the air that we breathe? Remember, was what element? It was, boy, these balloons are slippery. I'm trying not to pop one. Nitrogen. Nitrogen has that triple bond, one of the strongest bonds in nature, right? Well, at high temperatures, the nitrogen is able to break, and you're going to start getting your NOx's, as they call them, because you can get more than one oxygen on there. So now this starts a whole chain reaction thing going. You've got an NO. You can get an NO2. You can get N2O. Ay, ay, ay. What you eventually end up getting is an NO3 with the proton on the oxygen, nitric acid. Can we simulate one of those here? We need one more oxygen here. This is what a nitric acid would be. Nitrogen with 3 oxygens and the proton on the H. So this is nitric acid. This is going to be one of the products eventually when the water hits the NO that is made. So what do we do now? We got to write the chemical reaction. This is where chemistry gets boring, right, kids? Well, let's do it with colors and the way we do it, with our Schroeder diamonds. Our oil here, carbon compounds. Remember, what is carbon? Let's hone in a little bit here. Get a close-up of what's going on there. We are going to get, carbon is a diamond, right? Remember our diamonds? So this is going to go off. We'll just draw a little line here because these are continuous. So we've got one carbon bound to what? Another carbon. We'll draw the C's in there. So we're just going to use 2 of these. This would be the ethyl group off the end of that. CH3, what are the H's? These are our little dots, remember? So we got 3 dots. It's like something a court jester would have, right? So this is the ethyl portion of a carbon ring, carbon chain, I guess you'd call it. We'll write it up here with a different color marker, and we're talking about combustion. Combust ion. So combustion doesn't show up very good there, does it? Back up a little bit here. With the shine, it's not going to show either. Combustion is your carbon source plus O2. And what is our O2s? O's are our circles with 2 bounds. That's O2. Carbon with O2 goes on to make CO2 plus water, H2O. How are we going to draw that? CO2 is simply a diamond. And 2 for the O's, so here's 1 over here. 2 more on that. CO2. And what is our water? Simply O with